So this is factoring using bottoms up. So first step is factor out the GCF. Okay? So look at 6x squared, 14x, and 8. They all divide by 2, right? So divide a 2, we get 3x squared minus 7x plus 4 left inside. So let's go back to elementary school real quick. Let's think about the number 20 again. How does 20 divide out to begin with? 10 and 2 works, right?
Yes.
But would I stop there?
No.
No. So sometimes we factor something. So we have like 10 times 2, right? But you can actually factor it further. You have to factor it further to get to the prime numbers, right?
Yeah.
So technically what we did is we factored. We just factored out the greatest common factor, right?
Mm-hmm.
So with the number 20, I would now break it apart into 2 and 5, which makes 2 more factors, right? So how many factors do I end with? 3. 5 times 2 times 2. Okay? Well, the same thing happens with the quadratic. Sometimes after you factor out the GCF, you can factor what's left inside. So now for the rest of the problem, we're going to focus on this, which is a quadratic, right? In the form ax squared plus bx plus c. That's at the top of your bottoms up sheet. So what is the a value? 3. Just the number in front, right? Ax squared. The a is the number in front. What is the b value?
7.
Negative 7. It's important that you know it's negative. And what is c?
4.
Positive 4. Notice, I'm pretty much totally ignoring the GCF from here on out. Once it's out front, I don't really care about it anymore, other than the fact that it's going to stay out front, okay? So what I'm focusing on now, a is not 2. Does that make sense? A is the 3 that's left inside, okay? So now, Braden, read to us step 3 at the top of your bottoms up sheet.
Of what's left inside, multiply the a value times the c value.
Okay, so what is a times c? 12. And it's positive 12, right? Which means it's either a positive times a positive or a negative times a negative. It's the only way you can multiply to get a positive number, right? But what do we have to add up to in the middle? A negative number. So which scenario is this? They both need to be negative, right? Negative times a negative is a positive, but a negative plus a negative gets further negative. So now you just have to determine what times what is 12. That also adds up to 7. So if you want, you can kind of go through the numbers. We know 12 could be 1 and 12. It could be 6 and 2. It could be 3 and 4. But we know they both have to be negative, right? So now, which of these scenarios is the one that adds up to negative 7? It's this one right here. Does everyone see it? So, we're going to keep the GCF out front. So write the 2 out front. But we're splitting this red part, or this part right here, the part that was left, into 2 new factors. And in those factors go the 2 magic numbers that we just came up with. So x minus 3, x minus 4. We good so far?
What happened to the 3x squared though?
We broke it apart. We're breaking an x squared apart into 2 separate x's, just like you did on the packet, right? But we're not done yet. The main thing here that's different from the ones we did on the intro packet, what do you notice about A? It's not 1. Remember how all of the one on the introduction packet were 1x squared? That's why we're having to do this whole process right now, because A is not 1. If A was 1, we'd be done, right? We broke it apart and we're done. But currently, if you foiled this back, this is really important to understand. Ignore the GCF. If you foiled this out right now, what's x times x?
X squared.
And you see how that doesn't take us back to the 3 in front that we need to be 3x squared?
Yep.
So we know we're not done yet. Okay? So, I believe this is step number 5. No, it's step number 6. Cole, read to us step 6 on bottoms up.
2 x.
The words at the top of the page. Step 6.
Divide the factors that you just put into the parentheses by A.
Okay, so these are the factors we just put in parentheses, right? Our -3 and our -4. We need to divide them by A. So what was my A value again? We wrote it right up there.
3.
It's 3. You have to divide by 3. So this is the bottoms up portion of bottoms up, right? Now we actually have bottoms.
Yeah.
We have denominators now. We have fractions. We have a bottom to the fraction, okay? The next one is so important that I bolded it. Scott, can you read to us step 7? It's bolded at the top.
Go to yellow.
Simplify both fractions completely.
Simplify both fractions completely. Thank you. So, what is 3 divided by 3?
1.
1. Now, does 4 over 3 reduce any further?
No.
Do 4 and 3 both divide by the same number?
No.
No. So if it doesn't reduce, that's where we go to the very last step of bottoms up. Landon, can you read to us the very last step?
After simplifying remaining denominators, move up to the front of each x.
So the denominator moves to the front of its x. So the answer is 3x minus 4. Bottoms up. So does your answer have any bottoms in it? No, they've moved up, right?
Yeah.
Your answer shouldn't have fractions in it, ever, okay? So now, can you ignore the GCF, but now can you see what would happen if I foiled the first two terms?
X.
There's the 3 that we needed, right? Cole's very, very enthusiastic about that. Now we get the 3 back that we needed to get back to where we started, right? And then, if you multiplied the 2 through, where would we get back to?
6.
The 6 that we had to begin with. So I just want to point out one thing. So I'm making this up, but let's say we have this, and we have, sorry. Let's make it, I'm thinking ahead of myself. So let's make this 7. And then let's say from the very beginning the A value was 4. So when I do my bottoms, you have to divide by 4, right? Does 7/4 reduce? No, so we take the 4 to the front, right? We get 4x minus 7. But all the time I see people do this. But what is wrong about that?
And simplify.
Yeah, 2/4 simplifies to what?
1/2.
Yeah, that should be 1/2. So really, what's the number you should take to the front?
2.
The 2 and the 1 stays behind. You have to simplify, or the numbers in front are going to be too big. When you multiply it back out, it won't get you back to where you came from. So that happens a lot. So even if it's not as obvious of one, like maybe, I don't know, 15 over 35. That has to simplify. What's 15 over 35? 3 over 7. And then the 7 would go to the front. That's why I bolded that step, right? Number 7 is bolded. You have to simplify or your answer will be wrong. Okay? Let's say I have x squared minus 5x minus 6. First of all, actually stop what you're doing. This is really important that you understand this. Okay, so what is A right now? 1. What is B?
5.
What is C?
6.
-6. So what times what is -6? Those same two numbers add up to -5.
1.
Now, we know one has to be positive and one has to be negative.
No,
No?
it's not. It's 1 and -6.
2 times 3 is not negative. Right?
Negative
So you have to be careful. 2 plus 3 is 5, but that doesn't...
negative 6
1
plus
plus
1.
-6 plus 1. You see it? 1 times -6 is -6. It has to be negative. 2 and 3 wouldn't be negative. 2 times 3 is positive 6, right? So so that would go into the parentheses, right? So x plus 1 and x minus 6. So now, if I do the bottoms up, what do I have to divide by?
1.
Divide by 1, right? Because A was 1, that's what you have to divide by. Does dividing by 1 change anything? Does bringing 1 to the front change anything?
No.
That's why when A is 1, you basically don't have to do the whole bottoms up portion of bottoms up, right? You only have to do that when A is greater than 1. So for example, on the problems you're about to do, numbers 9, actually it's just 9, 8 has a GCF. Remember, that's always the first step is GCF. So when you pull the GCF out of 8, what's A going to be?
1.
1 x squared, because the 2 will be all the way up front. Okay, so go ahead and start working on those.